The world of modern aviation is a story of incredible machines. Two of the most famous are the Airbus A350 and the Boeing 787 Dreamliner. These are not just airplanes, they are marvels of engineering. They fly farther and use less fuel than older jets. They also offer a better experience for everyone on board. Airlines love them because they save money on fuel. Passengers love them because they feel more comfortable. These planes represent a huge leap forward in how we travel across the globe. They are the result of many years of research and design. Their story is a tale of competition and innovation between two great companies. Both the A350 and the B787 were born from a need for greater efficiency. As fuel prices rose, airlines needed planes that could fly long distances without burning a lot of fuel. Boeing was the first to answer this call with the 787 Dreamliner. It was a revolutionary idea. Airbus soon followed with its own amazing aircraft, the A350. Both planes share a common goal. They aim to be the most advanced and efficient jets in the sky. To achieve this, their designers used new materials, new engines, and new technologies. The rivalry between these two planes has pushed aviation technology forward in amazing ways. When you look at them on the tarmac, you might notice some differences. The Boeing 787 has a sleek, pointed nose. Its wings curve upwards in a graceful arc. The Airbus A350 has a more rounded nose, almost like a bandit's mask around the cockpit windows. Its wings also curve up, but they end in a distinctive, elegant winglet. These are not just for looks. Every curve and every shape is designed for a specific purpose. These designs help the planes cut through the air with less resistance. This is called aerodynamics. Better aerodynamics means the plane uses less power and less fuel to fly. These airplanes are part of a new generation of wide-body jets. A wide-body jet has two aisles inside the cabin, making it feel very spacious. They are designed for long-haul flights that can last for more than 15 hours. Journeys from New York to Singapore or from London to Sydney are now possible. The engineering behind these planes makes such long flights more bearable for passengers. The cabins are quieter. The air is less dry. Even the windows are bigger. These small details add up to a big improvement in the travel experience, making the world feel a little bit smaller for all of us. One of the biggest secrets to these planes is what they are made of. For many decades, airplanes were built mostly from aluminum. Aluminum is a strong and light metal, but Boeing and Airbus wanted something even better. They turned to a material called carbon fiber reinforced plastic, or CFRP. This is a composite material. It is made of strong carbon fibers woven together and set in a special plastic. The Boeing 787 is a true pioneer in this area. More than half of its structure, including the main body and wings, is made from composites. This was a radical change in aircraft manufacturing. The Airbus A350 also uses a lot of composite materials. Just like the 787, over half of its structure is made from advanced materials like CFRP. However, Airbus took a slightly different approach. Instead of making the entire fuselage barrel out of one piece, Airbus builds it using large composite panels. Both methods have their advantages. The key takeaway is that both planes use a massive amount of these lightweight materials. Using composites instead of metal makes the planes much lighter. A lighter airplane needs less power to fly. This directly translates to burning less fuel, which is a huge benefit for airlines and the environment. The benefits of carbon fiber go beyond just weight savings. This material is incredibly strong and does not corrode or rust like metal does. This is a very important feature for airlines. It means the airplanes do not need as many heavy inspections for metal fatigue or corrosion over their lifetime. This reduces maintenance costs and keeps the planes flying more often. The strength of composites also allowed engineers to design wings that are longer and more flexible. These advanced wings are more aerodynamically efficient, helping the plane to fly smoothly and use even less fuel. It is a win-win situation for the airlines. For passengers, the use of composites brings some surprising benefits. Because carbon fibre does not corrode, the air inside the cabin can be kept at a higher humidity level. The air on older planes is often very dry, which can be uncomfortable on long flights. On the 787 and A350, the air feels more natural and less dehydrating. The composite structure is also stronger, which allows the cabin to be pressurized to a lower altitude. Instead of feeling like you are at 8,000 feet, it feels more like 6,000 feet. This reduces travel fatigue, headaches and dizziness, making you feel more refreshed after a long journey. An airplane is nothing without its engines. The engines on the A350 and B787 are just as revolutionary as their airframes. They're designed to be incredibly quiet and fuel efficient. For the Boeing 787, airlines have a choice between two different engine types. One option is the General Electric GNX engine. The other is the Rolls-Royce Trent 1000. Both are masterpieces of modern engineering. They use advanced materials and clever designs to squeeze every bit of power from each drop of fuel. They also have a special scalloped or chevron pattern on the back of the engine casing, which helps to mix hot and cold air. This simple trick makes the engines much quieter. The Airbus A350 has one exclusive engine provider, Rolls-Royce. The engine is called the Trent XWB. The XWB stands for extra wide body, as it was designed specifically for this airplane. The Trent XWB is currently one of the most efficient large jet engines in the world. It is an evolution of the same technology used in the 787's Trent 1000 engine. It has a very large fan at the front. This fan moves a huge amount of air around the engine core rather than through it. This is called a high bypass ratio. This design makes the engine incredibly efficient at cruise speeds and also significantly reduces noise levels. The competition between engine makers is fierce. General Electric and Rolls-Royce are constantly pushing the boundaries of what is possible. They use new metal alloys that can withstand extreme heat and pressure. The fan blades at the front of the engines are often made from lightweight composite materials or hollow titanium. Every component is optimized to save weight and improve performance. This continuous innovation means that each new generation of engines is about 15 to 20% more fuel efficient than the ones they replace. This is a massive improvement that has a direct impact on the cost of air travel and its effect on the planet. For airlines, the choice of engine is a major decision. It affects not just fuel consumption, but also maintenance schedules and costs. Some airlines might already have a large fleet with engines from one manufacturer, so they prefer to stick with them. This simplifies their maintenance operations and spare parts inventory. For passengers, the result of all this engineering is a much more pleasant flight. The reduced engine noise means the cabin is quiet enough for a normal conversation. You can watch a movie or listen to music without turning the volume all the way up. It is a small but significant improvement in comfort. The cockpit is the brain of the airplane. In the A350 and B787, the cockpits are more like something from a science fiction movie than an old airliner. They are dominated by large, high-resolution LCD screens. These screens replace the dozens of round dials and gauges found in older planes. On the Boeing 787, pilots have large displays that they can customize to show the information they need. A key feature is the head-up display, or HUD, for both pilots. A HUD is a transparent screen that projects critical flight information in the pilot's line of sight. This means they can see data like speed and altitude while looking out the window, which is very useful during takeoff and landing. The Airbus A350 cockpit looks very similar at first glance. It also features large screens that display all the flight information. However, Airbus has a philosophy of communality. This means they design their cockpits to be as similar as possible across their different airplane models. A pilot trained on an Airbus A320 can transition to the much larger A350 with less training time. This saves airlines a lot of money and makes scheduling pilots more flexible. The A350 also has a clean and ergonomic design. with keyboards and trackballs for pilots to interact with the flight systems, much like using a computer. These advanced cockpits do more than just look cool. They are designed to improve safety and reduce pilot workload. The flight management systems can automatically calculate the most efficient flight path, taking into account weather and wind conditions. They can monitor the health of the entire aircraft in real time and alert the pilots to any potential issues before they become serious problems. This high level of automation allows pilots to focus on the big picture of managing the flight safely. It is a partnership between the human pilots and the smart technology of the aircraft. For passengers, the benefits of these planes are clear. The Boeing 787 is famous for its large, dimmable windows. Instead of a plastic shade, you can press a button to electronically tint the window, allowing you to see outside while reducing the glare. The Airbus A350 has very wide cabins, which can give a sense of more personal space. Both aircraft feature advanced air filtration systems and LED mood lighting that can be changed to match the time of day, helping to reduce jet lag. In the end, both the Boeing 787 and the Airbus A350 are incredible achievements. The 787 is a bold revolutionary, while the A350 is a smart evolution. Together, they have changed the sky for the better. For more fascinating aviation insights, follow and subscribe at Aviation Tech.